In 1919, a relatively unknown mathematician sent Albert Einstein a letter. The letter contained a proposal, a single, elegant idea. What if you took Einstein's own equations for gravity, the ones that had just rewritten our understanding of space and time, and extended them into a fifth dimension? Einstein read it. And then he did something he almost never did. He sat on it for 2 years. Not because it was wrong, because it was too right. The math worked perfectly. When you wrote Einstein's field equations in 5 dimensions, something extraordinary happened. Electromagnetism, the second fundamental force of nature, fell out of the equations automatically. You didn't add it. You didn't assume it. It just appeared. Gravity and electromagnetism, unified, in a single equation, by adding one dimension nobody could see. Einstein spent the last 30 years of his life searching for a unified field theory, a single mathematical framework that could describe all the forces of nature. He never found it. Theodor Kaluza handed it to him in 1919. And the answer required a dimension beyond the ones we can perceive. That was 107 years ago. Since then, string theory has extended the idea to 10 dimensions. A Harvard physicist used the 5th dimension to explain why gravity is the weakest force in nature. The Large Hadron Collider has been specifically searching for physical evidence of extra dimensions. And in 2025, researchers announced they may have found a particle that functions as a literal portal into the 5th dimension. The math has always pointed here. The question is, what's on the other side? Theodor Kaluza was not a famous physicist. He was a mathematician at the University of Königsberg, a mid-career academic with no particular celebrity in the field. In April 1919, he sent Einstein a paper. Its central idea, general relativity, Einstein's theory of gravity, which describes space and time as a 4-dimensional fabric that curves in the presence of mass, could be extended to 5 dimensions. The 5th dimension in Kaluza's framework was spatial, a physical direction, like left-right or up-down, but curled into a circle so small it was undetectable. He called this compactification. When Kaluza ran the mathematics of general relativity in 5 dimensions, and then extracted the 4-dimensional version, essentially asking, what does the 5D theory look like from inside a 4D world? He found something that stopped him cold. The extra terms in the equation, the ones that came from the 5th dimension, they were Maxwell's equations. Maxwell's equations are the mathematical description of electromagnetism, the theory of light, electricity, and magnetic fields. One of the most precisely tested frameworks in all of physics. They appeared, spontaneously and completely, from the geometry of a 5th spatial dimension. Einstein wrote back immediately, "The idea of achieving unification by means of a 5-dimensional cylinder world never dawned on me. At first glance, I like your idea enormously." Then he held the paper for 2 years. He kept looking for the flaw. He couldn't find one. The paper was published in 1921. It launched a century of physics that is still unresolved. The obvious question, if there's a 5th spatial dimension, why can't we see it? Why can't we move in it? Why doesn't it show up in any experiment? Kaluza's answer, refined in 1926 by Swedish physicist Oskar Klein, is compactification. Imagine a garden hose. From a distance it looks one-dimensional, just a line. But up close it has 2 dimensions, the length along the hose and the circular cross-section wrapping around it. An ant walking on the hose can move along both dimensions. But from far enough away, the circular dimension is invisible. The 5th dimension, in Kaluza-Klein theory, is curled up into a circle, but the radius of that circle is approximately the Planck length, 10 to the power of -35 meters. That is 20 orders of magnitude smaller than a proton. There is no instrument built, no instrument conceivable with current technology, that could probe that scale directly. The dimension is real. It is there. It is just incomprehensibly small. String theory, the most mathematically sophisticated attempt to unify all forces of nature, extends this idea to 10 or 11 dimensions. 6 or 7 additional spatial dimensions, all compactified at the Planck scale, curled into complex geometric shapes called Calabi-Yau manifolds. The strings of string theory, the fundamental units of matter and energy, vibrate in these extra dimensions. Different vibration patterns in different dimensional configurations produce different particles. The entire particle zoo of the Standard Model, every electron, every quark, every photon, is in principle the result of strings vibrating in 10-dimensional space. The math works. The problem is we can't test it. A century of physics pointing at dimensions we can't see, and new evidence suggesting we're leaking into one right now. Subscribe. Things that shouldn't exist goes this deep every single week. Here is a question that has bothered physicists for a century and has never been satisfactorily answered. Gravity is the weakest force in nature, by an almost incomprehensible margin. The electromagnetic force is 10 to the power of 36 times stronger than gravity. That is 1 followed by 36 zeros. A small magnet can lift a paperclip against the gravitational pull of the entire Earth. Why? What is the physical reason that gravity, which curves spacetime, holds galaxies together, determines the large-scale structure of the universe, is so extraordinarily weak at the particle scale? In 1999, Lisa Randall and Raman Sundrum at Harvard published a paper that answered this question using the fifth dimension. Their model, now called the Randall-Sundrum model, proposes that our universe is a three-dimensional membrane, or brane, floating in a five-dimensional space called the bulk. Gravity originates on a different brane and has to travel through the fifth dimension to reach ours. In traveling through the extra dimension, gravity dilutes. It spreads through a space we can't access. By the time it reaches our brane, it has weakened by exactly the factor that matches what we observe. Gravity isn't weak. It's leaking into a dimension we cannot directly detect, losing most of its strength before it reaches us. The Randall-Sundrum paper was not fringe physics. It was published in Physical Review Letters and has been cited over 10,000 times. It is one of the most influential papers in theoretical physics of the last 30 years, and it requires a fifth dimension to be physically real. If extra dimensions exist, and the Randall-Sundrum model predicts they should be detectable, the Large Hadron Collider at CERN should be able to find them. The specific signatures physicists have been searching for. Micro-black holes. If extra dimensions exist, the energy threshold for creating a microscopic black hole drops dramatically, potentially within reach of LHC collision energies. The CMS detector at CERN has conducted dedicated searches for micro-black hole signatures in high-energy proton collisions. Missing energy. In the Randall-Sundrum model, gravitons, the hypothetical particles that carry gravity, can escape into the fifth dimension during high-energy collisions. This would show up as collisions, where the measured energy of the products is less than the energy that went in. Energy that disappears into another dimension. Kaluza-Klein towers. If extra dimensions exist, particles should have heavier copies of themselves, excitations corresponding to momentum in the extra dimension. These Kaluza-Klein particles would show up as new, heavy versions of known particles in collision data. The LHC has searched for all of these. So far, no confirmed detection. But here is what that means, and doesn't mean. The absence of micro-black holes at LHC energies rules out certain models of large extra dimensions. It does not rule out the Randall-Sundrum model, which predicts a warped geometry that pushes the signatures to higher energies than the current LHC can reach. The high-luminosity LHC upgrade, currently being installed, will increase collision energy significantly. The search continues. The door hasn't been found. The math still says it's there. In 2025, a research team published a paper proposing a specific particle that could function as a literal portal into the fifth dimension. The particle is a heavy fermion, a matter particle with mass that exists in a warped fifth-dimensional geometry consistent with the Randall-Sundrum model. In their framework, fermion mass, the property that gives matter particles their weight, is not intrinsic to the particle. It is generated by the particle's interaction with the fifth dimension. The fermion passes through a portal into the fifth dimension, acquires mass there, and returns to our brane. The paper makes a specific prediction. This portal fermion would mix with the Higgs boson, the particle discovered at CERN in 2012 that gives all particles mass in a way that would be detectable in high-luminosity collider experiments. If confirmed, it would be the first direct experimental evidence of a particle interacting with an extra dimension. And in April 2026, last month, a NASA scientist published a paper proposing that a mysterious fifth force hiding in the cosmic web, the large-scale structure of filaments and voids that make up the universe, may be evidence of a fifth dimension operating at cosmological scales. The Uppsala University model, published in 2024, proposes that our universe is an expanding bubble riding on the surface of a five-dimensional space. Dark energy, the mysterious force accelerating the expansion of the universe, currently unexplained by any standard model physics, is in this model the pressure of the fifth dimension pushing the bubble outward. We are not just floating in a fifth dimension, we may be propelled by it. Here is where physics and something else collide. The interdimensional hypothesis, proposed by Jacques Vallée in the 1970s, is now gaining serious traction in UAP research circles. suggests that unidentified aerial phenomena are not extraterrestrial in origin. They are not craft from another star system traveling through conventional space. They are intersections, points where something from a higher dimensional space intrudes into our three-dimensional brain. In the Randall Sundrum framework, our universe is a brain in a five-dimensional bulk. The bulk is real. It has geometry. It can, in principle, contain things. A civilization existing in the bulk, or on a parallel brain in the same bulk, would have access to our universe in a way that would appear, from our perspective, as objects appearing and disappearing without conventional propulsion, moving through our space by navigating the extra dimension, rather than traversing the three dimensions we can observe. The physics does not confirm this, but the physics does not rule it out. What the physics does confirm: extra dimensions are not science fiction. They are a serious, mathematically rigorous, experimentally motivated framework that represents the current frontier of theoretical physics. The beings in ancient traditions that appear and disappear, the UAP that accelerate beyond any known propulsion limit, the objects that witnesses describe as seeming to phase in and out of physical reality. If they are real, and the documented record suggests something is, the fifth dimension is the most physically coherent explanation for how they do it. In 1919, Theodor Kaluza showed Einstein that adding a fifth dimension unifies gravity and electromagnetism. Einstein couldn't find the flaw. In 1926, Oscar Klein explained why we can't see it, curled up at the Planck scale, 20 orders of magnitude smaller than a proton. In 1999, Lisa Randall and Raman Sundrum used it to explain why gravity is the weakest force in nature. It's leaking into a dimension we cannot access. In 2012, CERN confirmed the Higgs boson, the particle that may, according to 2025 research, mix with a portal fermion connecting our universe to the fifth dimension. In 2024, physicists proposed that dark energy, the force accelerating the expansion of the entire universe, is the pressure of a fifth dimension pushing our reality like a bubble through a higher dimensional space. And last month, a NASA scientist proposed a fifth force, hiding in the large-scale structure of the cosmos, that may be evidence of a fifth dimension operating at scales we've only recently begun to measure. The math has been pointing here for over a century. The experiments are getting closer. The evidence is accumulating from multiple independent directions. The fifth dimension is not a metaphor. It is not mysticism. It is the conclusion that the most rigorous mathematics in human history keeps arriving at, from Einstein's field equations to string theory to the cosmological data coming in right now. Something is there. We just can't see it yet. Drop a comment. If extra dimensions are physically real, what does that change about everything else we think we know? Next week on Things That Shouldn't Exist, the Antikythera mechanism, a 2,000-year-old Greek device that is a fully functional astronomical computer. The engineering required to build it shouldn't have existed for another 1,400 years. And the civilization that built it apparently lost the knowledge entirely. Subscribe. I'll see you there.